Question number 8 from exercise 6.1. The chapter is lines and planes, and right now we are working on lines. Question is, A is -2, 3, 4, B is 1, 1, 2, and C is 4, -1, 0 are 3 points. Find the Cartesian equations of the line AB. Of the line AB. Okay, now when they say line AB, we will take points A and B. Okay, of the line AB, and show that points A, B, C are collinear. So that is the next part of the question. First, we have to find the Cartesian equations of line AB. So see, how do we begin? First of all, what I will do is I will find the DRS of AB. Okay, I will write here DRS of line AB is given by, see, DRS of AB will be 1 minus of -2, 1 minus of -2, comma, 1 minus 3, comma, 2 minus 4. So this is 3, -2, and -2. What are the DRS? DRS of line AB are given by, DRS of line AB are given by. So we got the DRS of AB, 3 minus 2 minus 2. Okay, this we have already done. If you have 2 points, then how do you get DRS of that line on which the 2 points lie? If you have points as say A, x1, y1, z1 and B as x2, y2, z2, then how do you get the DRS? DRS of AB is x2 minus x1, y2 minus y1 and z2 minus z1. Okay, remember. I'll do one thing. I will write this as a reference. Let me write it here as a reference. If A is this, B is this, then DRS of AB bar, DRS of AB bar are given by x2 minus x1, y2 minus y1, z2 minus z1. Okay, now the next here is, after this I will write the equation of AB. Now you know the equation of the Cartesian equations are given by, I will write here, therefore the Cartesian equations of line AB can be given by, or can be given as, it can be given as you know, it is x minus x1 upon a1 equals to y minus y1 upon b1 equals to z minus z1 upon c1, right? So x minus x1, what are x1, y1 and z1? They are the coordinates of points, coordinates of a point on the line. So we will take that point as A. So x1, y1, z1 are -2, 3, 4. So x minus of -2 upon a1. What are a1, b1, c1? They are the DRS. So the DRS is 3. You understand? 3 minus 2 minus 2. So upon 3, y minus y1. What is y1? Y1 is, I'm taking point as A. So if you're taking point as A, then 3. Y1 is 3 and Z1 is 4. 3 and B1. B1 is -2. Z minus Z1. Z1 was 4 and C1. C1 is minus 2. So you have x plus 2 upon 3 equals 2. Y minus 3 upon minus 2 equals to Z minus 4 upon minus 2. This is the answer. Okay. This completes the solution. Now we have to, so we got the Cartesian equations. Now what they say show that points A, B and C are collinear. You have to show that these points are collinear. Okay. We will go for the second. We go for the second part to prove that points A, B and C are collinear. I will write here to prove that points A, B and C are collinear. Okay. What I will do is, see, the coordinates of C are, point C is, what are the coordinates of point C? Coordinates of point C are 4 minus 1 0. It is 4 minus 1 0. I will write put x equals to 4, y equals to minus 1 and z equals to 0. See, this is x, this is y, this is z. Put x equals to 4, y equals to minus 1 and z equals to 0 in equation 1 here, in 1. So let's put it and see what are we getting. So see, 4 plus 2 upon 3. 4 plus 2 upon 3 equals to minus 1 minus 3. Y is negative 1. So minus 1 minus 3 upon 2 minus 2 equals to Z is 0. 0 minus 4 upon minus 2. So what do we get? We get 6 by 3 equals to minus 4 by minus 2 equals to minus 4 by minus 2. 6 by 3 is 2 equals to, this is 2 and this is also 2. So what do we follow? We followed that the coordinates of point C satisfy the equation of line AB. This is equation of line AB, not to be forgotten. This is equation of line AB. You have found equation here, you found equation of line AB. So after having substituted the coordinates of point C, I noticed, see, I'm getting 2 equals to 2 equals to 2. It means the coordinates of point C are satisfying equation of line AB. I write here, therefore, point C satisfies equation of line AB. Now, when we all know, when a point satisfies equation of a locus, it means the point lies on the locus. So here I will say, therefore, point C lies on line AB. Now listen, students, if point C lies on line AB, that means the 3 points are collinear. If the point lies on the line, see, this is AB. Suppose this is AB. This is A. This is B. AB. And point C lies on it. What does that mean? That means that 3 points are collinear points. Therefore, I will write, therefore, the 3 points, therefore, points A, B, and C are collinear points. Very simple problem. Please copy this. Okay, after having solved question number 8, the one that I just solved, now question number 6 and 7. See, these two questions are extremely simple because we have in question number 8 we covered the same point. Question number 6 is find the Cartesian equations of a line passing through a minus 1, 2 minus 1 and having direction ratios 2, 3, 1. So now you know if you are given the point on the line and you are given DRS of the line, very easily you can write the equation as we wrote here. You see this? This is the one. So these are x1, y1 and z1 are the coordinates of the point on the line. A1, B1, C1 are the DRS of the line. Okay, so you will just substitute in place of x1, y1, z1, a1, b1, c1. Okay, you will substitute in place of x1, y1, z1 these three, and in place of a1, b1, c1 you will substitute these three. You do this much and the equations in Cartesian form are ready. The next one is question number 7. Find the Cartesian equations of the line passing through A 2 to 1 and B 1 3 0. A 2 to 1 and 1 3 0. It is very much similar to problem number 8. There also we had the similar question. You know, we are given 2 points on the line and we need to find the Cartesian equations of the line. So what we do, we will first find the DRS of the line. Okay, DRS we will find out, that is DRS of line AB will be x2 minus x1 comma y2 minus y1 comma z2 minus z1, and after that you take a point and you use the DRS to write the equations in Cartesian form. So these two equations you can solve. Question number 9. Look at this question. This question is very interesting question. Show that lines, which two lines? X plus 1 upon minus 10 equals to y plus 3 upon minus 1 equals to z minus 4 upon 1, and this line intersect each other. We have to show that these two lines are intersecting each other. They are intersecting each other. Okay, first of all, understand that these two lines are lines in space. What are they? They are lines in space. So these two lines, we have to show that they are intersecting each other. After that, they are saying find the coordinates of their point of intersection. We have to find the coordinates of their point of intersection. Okay. Okay, so now we will begin with the solution of this question. And for your reference, I have drawn this diagram. Now in this diagram, you see here 3 lines. Let us call this orange line as line 1. And the yellow line as line 2. This one, we will call it as line 3. Okay. So L1, L2 and L3, we have got 3 lines. Now in this, see, none of these lines are parallel to each other. None of them. They are not parallel to each other. You understand the meaning of parallel lines. Now see here, L1, L2, L3, they are not parallel to each other. They are not parallel to each other. Now what we have studied in 2D plane, I will take you to 2D plane. See, if I have a 2D plane where I have y-axis and x-axis, this is 2D plane. And we have studied in 2D plane that if there are 2 lines which are not parallel, suppose I have 2 lines here and these 2 lines are parallel lines. So we have studied that if the 2 lines are parallel lines, they will never intersect each other. If 2 parallel lines are there, they will not intersect. I once again tell you that this is in a plane. It is in a plane. This is 2D plane. It is not 3D space. It is 2D plane, X and Y axis. That's it. It's a plane of paper. It's a plane of whiteboard, blackboard, whatever you say. It's a plane. It's a plane. So in a plane, if two lines are parallel, then what will happen? They will always be at a fixed distance from each other. And if you have two lines which are not parallel, suppose I have another line which is not parallel, okay, so it's a matter of extension. See, I have not extended it, but if I had extended, it would have definitely intersected. See here, if I extend this, the line is not parallel, so now let me extend it. See, it will intersect. It will definitely intersect. It will intersect both of these lines. Why? Because L6 is not parallel to L4 and L5, so they will intersect. Okay, this is about 2D, but now let's come to 3D. In 3D we have slightly different concept. In three-dimensional space we have slightly different concepts. Okay, I have tried my level best to make you understand that. See, in order you understand the three, you get the 3D idea. I have drawn these two planes and I'm making the lines intersect these planes. Okay, so a part of the line which is behind the plane you do not see. It is just in order to make you feel that these are lines in space. Okay, as such, remember, here the planes which I have drawn, this plane or this plane I have drawn, the planes are not that significant. What is significant? The lines are significant. Okay, they are important, but the plane is helping you to have a visual effect of 3D. Now in this, what you understand is line L1 and L2, they are not parallel and they intersect each other at this point. See, they are not parallel and they are intersecting. They are not parallel, they are intersecting. See, if they were parallel, if the two lines had been parallel, they would not have intersected. That is for sure. If the two lines are parallel, they will never intersect each other. That is for sure. Here two lines are not parallel, L1, L2, they are not parallel, they are intersecting. Now look at L1 and L3. L1 and L3 are not parallel, but they are not intersecting. This is what I wanted to explain. This is something different from the 2D concept. I repeat once again. L1 and L3 are not parallel, but they are not intersecting. They are not intersecting. What is happening is L3 line is passing over L1. See, it is passing over L1. Here what you see, okay, since you have here, I'm explaining this everything in 2D, so you may not understand this, but remember that this L3 line is passing over L1. It is over L1. There is a distance between two here. Okay, in order to make you understand, I can give you an example. Think of two pencils in your hand. Okay, think of two pencils in your hand. Okay, now one pencil you hold in your left hand, the other pencil in your right hand, and you hold them in such a way that they are not parallel, they are crossing each other. They are not parallel, they are crossing each other and they are one over the other. They are not parallel. You don't hold them parallelly, you hold them in such a way that they are crossing each other, but make sure that they are not meeting each other. They are one over the other. They are one over the other. So such two lines which are not parallel but they are not intersecting are known as skew lines. They are known as skew lines. What are skew lines? Remember, those lines which are not parallel, but they are not intersecting. What are skew lines? Those are the lines which are not parallel. They are not parallel, but they will not intersect each other. Okay, in this is something we have different from 2D. In 2D, what used to happen, if two lines are not parallel, they will definitely intersect because they are all in one plane. You cannot have a line over the other line, but here you can definitely have one line over other line. See, L3 is over L1. L3 is over L1. I hope you followed what I just said. So in this question, I have to prove, I'm given two lines. I'm given two lines here, and what I have to prove? I have to prove that these two lines are intersecting each other. Okay. So let these two lines be L1 and L2. Okay, let these two lines be L1 and L2. L1 and L2, anyways, I made them intersect each other. Now remember, students, if the two lines are intersecting each other, then they will have one point in common. Both of these lines will have one point in common, that is for sure. Okay, so now this idea of common point will give us the solution. Okay, so I will begin with my solution. So here I write my answer. See, I write the given lines are x plus 1 over minus 10 equals to y plus 3 over minus 1 equals to z minus 4 over minus 1 over 1 equals to lambda. I take this as lambda. Okay, they all are equal and they are equal to lambda. What is lambda? Lambda is a parameter. Okay, they all are equal. They all are equal, so has to be equal to one real number. Okay, so here I write where lambda belongs to r. Lambda is a parameter. Okay, so this is one line. So what will happen next? Now remember, students, in this equation, what does xyz signify? xyz xyz in this equation, they signify a variable point. X, y, and z are the coordinates of variable point. If you remember all those problems we solved, in all those problems, wherever we found the equation of a line, we took x, y, z as the coordinates of variable point. So what does x, y, z signify? It signifies the coordinates of variable point. So here I write, therefore a variable point on above line can be given as, how to give a variable point? See, we can give a variable point on the above line as, see, what will be x equal to? X equals to minus 10 lambda minus 1. See, this whole thing is equal to lambda. So when you multiply minus 10 with lambda, minus 10 lambda, and then shift 1 on the left, so you have minus 10 lambda minus 1. Okay, and what's y equal to? Y equals to minus lambda minus 3, and z equals to lambda plus 4. Okay, so a variable point can be given as minus 10 lambda minus 1 comma minus lambda minus 3 comma lambda plus 4. Okay, the given lines are, so I take this line as L1. So let me write here L1. The given lines are L1. Okay, for L1. So a variable point on line L1 can be given as. So see this is x coordinate, this is y coordinate, and this is z coordinate of the variable point. Okay, of the variable point, right? Now I go for line L2. So I write here for L2. For L2. For L2, I write. What is the equation? X plus 10 upon minus 1 equals to y plus 1 upon minus 3 equals to z minus 1 upon 4. Okay, equals to mu. What is mu? Just like we're there, as we took lambda here, a parameter, we are taking mu here, a parameter. Okay, where mu belongs to r and mu is a parameter, right? So I will now write, therefore a variable point on line L2 can be given as, it can be given as how? X equals to minus mu minus 10, minus mu minus 10, y equals to minus 3 mu, x equals to minus mu minus 10, y equals to minus 3 mu minus 1, and z equals to 4 mu plus 1. Okay, that is what will be the variable point here? See, minus mu minus 10 comma minus 3 mu minus 1 comma 4 mu plus 1. Okay, very nice. Now everybody look at this, here. You know, here this is x coordinate, y coordinate, and z coordinate of a variable point on L1. What are these three? They are x, y, and z coordinates of a variable point on line L1. It means L1 has infinite points on it. Line L1 has infinite points on it, and all these points can be given with the help of these three numbers. How? How can these three numbers in lambda represent infinite points? You know the reason, because lambda is a real number. What is lambda? Lambda is a real number. So for every lambda, there will be, suppose I take lambda as 1. So when I take lambda as 1, see what will this become? This will become minus 11 comma minus 4 comma 5. This is 1 point. You see this? If I took lambda as 2, it will become minus 21 comma minus 5 comma 6. This is another point. And this is, I'm taking lambda only as integer. I could go for fractions. I can go for decimal numbers. I can go for infinite lambda values. And for every lambda value, there is a point on L1. There is a point on L1. So remember, students, this point P will also have its coordinate given by these three. But the only thing is we do not know that lambda value. Even point P lies on L1. So point P can also be given by these three. Yes. Point P will have coordinates as this. Okay. Moreover, point P lies on L2 as well. Point P also lies on L2. and a variable point on L2 is given by this. A variable point on L2 is given by these three numbers. And interestingly, these three numbers will also give the coordinates of point P. These three numbers, X number, Y number, Z number, they will also give the coordinates of point P for some specific mu value, for some specific mu value, for some specific mu value. But what we understand that point P is a single point. Point P is a single point. So the coordinates of P will be unique. Whether I find the coordinates of P with the help of lambda or with the help of mu, the coordinates will be unique. Okay, what does that mean? It means that X coordinate here will be same as X coordinate here. Y coordinate here will be same as Y coordinate here. And Z coordinate here will be same as Z coordinate here. Okay, so here I begin. See, how do I start writing? I write here, if lines L1 and L2 intersect each other, if lines L1 and L2 intersect each other, then there will be a common point, on L1 and L2. Okay, in such a case, see, this X coordinate will be equal to this X coordinate. So what I will write? I will write minus 10 lambda minus 1 minus 10 lambda minus 1 equals to minus mu minus 10. Okay, minus mu minus 10. This is number 1. Further, minus lambda minus 3 minus lambda minus 3, because that Y coordinate should be equal to this Y coordinate, minus 3 mu minus 1, and lambda plus 4 equals to 4 mu plus 1. This is 3. So I will have here C. That is, now write them properly, minus 10 lambda plus mu equals to minus 9. And here you have minus lambda plus 3 mu, okay, equals to plus 2, and lambda minus 4 mu equals to minus 3, right? They are same equations, 1, 2, and 3. They are same equations, no change in the equation. Okay, now see, if these three equations, I have total 3 equations in lambda and mu. If these 3 equations are consistent, that is, there lies some lambda and mu for which these 3 equations are true. There exists some lambda and mu for which these three equations are true, then we can say that there exists a common point, and hence we can say that the two lines are intersecting. The two lines are intersecting. Now, in order it happens, what should happen? I should get some lambda value and some mu value. I should get some lambda value and some mu value for which these three equations are true. That is x, y, z on L1, x, y, z on L2, they are same. If a point having x, y, z on L1 also have the same x, y, z on L2, it means that point is on both the lines, and hence if two lines have a common point, it means they are intersecting each other. So what is the aim now? Now my aim is to show that these three equations are consistent. My aim is to show that these three equations are consistent. For them, for proving them consistent, there are two ways you can do it. See, you can solve any two equations. Like suppose I solve here, I solve for lambda and mu here in 2 and 3, and whatever lambda and mu I get by solving 2 and 3, I substitute that in 1, and suppose it satisfies what I get from 2 and 3, I substitute in 1, and if the value of lambda and mu satisfies the equation 1, that means there exist lambda and mu such that the xyz on L1 and xyz on L2, they are equal, and hence there is one common point, and hence the two lines are intersecting. So what I will do, see, this is one way I can do it. The other way of doing is, the determinant method. I will form a determinant. And if the determinant value is 0, then the three equations in two variables are consistent. So I will write here, if, see, if above three equations are consistent, then we can say that there exist lambda and mu such that a point on L1 is also a point on L2. A point on L1 is also a point on L2 because the coordinates are same for that point. Okay, so here I will, okay, so here I write to show that equations are consistent. Okay, see, you will make a determinant and find the value. What is determinant? Minus 10, 1, minus 9. Minus 10, 1, minus 9. See, I showed you both the methods, whichever you like. Minus 1, 3, 2. Minus 1, 3, 2. Minus 1, 3, 2. And 1 minus 4 minus 3. 1, 1 minus 4 minus 3. You will solve this determinant. So what is it equal to? It is equal to minus 10 into minus 9 plus 8 minus 1 into, I hope you know how to evaluate the determinant, 3 minus 2 minus 9 into 4 minus 3. So here you have 10 minus 1 into minus 9, 10. This is minus 1 and this is minus 9. So 10 minus 10 equals to 0. Okay, we got 10 minus 10 equals to 0. Okay, therefore the above three equations are consistent. Therefore L1 and L2 intersect each other. Okay, now what we have to do? See, we have to find the value of point of intersection. I'm sorry, not the value. We have to find the coordinates of point of intersection. So in order to find the coordinates of point of intersection, finding lambda and finding lambda or mu is essential. That we have to do. So for that we will solve equation 2 and 3. So I write adding 2 and 3. Adding equation 2 and 3, see what I get. I write here adding equation 2 and 3. So here I write adding equation 2 and 3. So when I add equation 2 and 3, see, minus lambda plus lambda, it's gone. I get minus mu. On the left hand side, I get minus mu. I get here minus mu equals to minus mu on the left equals to minus 1. So what is mu? Mu equals to 1. And now what you will do? You got mu value. That is enough. You will substitute mu value here. You remember what is this? This is the way you represent a variable point on L2. Remember, this is representing infinite points. Why? Because for every point there would be a specific mu value. So when you are getting mu value as 1, that value mu equal to 1 is very specific for this point. When you put mu 1, you get this point, which is the point of intersection. So I write here, okay, therefore the point of intersection is, what is it? It is, substitute mu as 1. So this is minus 11 minus 4 5, minus 11 minus 4 5, minus 11 minus 4 and 5. Okay, I hope you followed it. In case if you haven't followed this, I would suggest you listen to this whole solution at least 2 times, solve this on your own. You will definitely understand. Okay, it's a good question. Such questions come for 4 marks.